Concurrent deviation. Correlation measures the relationship between two variables and shows whether and how strongly pairs of variables are related. Sometimes we are more interested in understanding the direction of the relationship, whether it is positive or negative. Concurrent deviation provides the direction of correlation. What is concurrent deviation? The coefficient of concurrent deviation is a simple and qualitative method to measure the direction of a relationship between two variables. If both variables increase together or decrease together, their changes are said to be concurrent, aligned. If one variable increases while the other decreases, their changes are non-concurrent, not aligned. Coefficient of concurrent deviation is denoted by RC and defined as frac 2c minus k, where k equals n minus 1, total number of paired observations minus 1. C is the number of concurrent deviations or the number of plus signs in the product of two deviations. If the coefficient RC is positive, the variables generally move in the same direction. If the coefficient RC is negative, they move in opposite directions. If the coefficient is 0, there is no consistent direction of change between the two variables. How to calculate concurrent deviation? The first value of series X is taken as a base and is compared with the next value, the second value of series X. If the second value is greater than the first value, assign a plus in the column titled dx. If the second value is less, assign a minus in the column dx. If first and second values are equal, then equal sign is assigned. The second value is then taken as the base and compared with the third value of the series. If the third value is less than the second, assign a minus sign against the third value. If the third value is greater, assign a plus. If the second and third values are equal, assign a equals. This procedure is repeated up to the last value of the series. Similarly, obtain column dy for series y. Multiply dx and dy to obtain column dx dy. Minus multiplication of the same signs results in plus. Multiplication of different signs results in minus. Finally, count the number of plus signs in column dx dy. This count is C. Use the formula to calculate the coefficient of concurrent deviation. In the formula, inside and outside the square root, the sign plus or minus depends on the value of 2c minus k. If 2c minus k is positive, use plus. If 2c minus k is negative, use minus. Let's do one example. Find the coefficient of correlation between supply and price by concurrent deviation method for the following data. The second value is greater than first value, plus sign is assigned in the column dx. The second value is increased, plus sign is assigned. The second value is decreased, minus sign is assigned. The second value is decreased, minus sign is assigned. The second value is increased, plus sign is assigned. Similarly, we obtain column dy for price multiply dx, and dy multiplication of same sign results plus sign, and that of different sign is minus sign. Number of plus signs, c equal to 2. If we put everything in, the correlation between supply and price is negative. This method works well when exact data, millimeters of rainfall or tons of crops, is unavailable, but the direction of change can still provide meaningful insights. Let's do another example, analyzing the relationship between the amount of rainfall and crop yield over 5 years in a region. We don't have the exact measurements for rainfall or crop yield. Instead, we only know whether rainfall increased or decreased compared to the previous year. Crop yield increased or decreased compared to the previous year. Rainfall increased from year 1 to year 3, then decreased in years 4 and 5. Crop yield followed a similar trend, increased with more rain, decreased with less rain. All changes in rainfall and crop yield are concurrent, that is, they moved in the same direction for all 4 comparisons. Since c equals 4, all changes are concurrent, and n equals 4, total comparisons, the concurrent deviation is RC equals 1. The correlation between rainfall and crop yield is perfectly positive, indicating that increases or decreases in rainfall always correspond to increases or decreases in crop yield. When to use concurrent deviation? Use concurrent deviations when you only care about the direction of change, not the exact values. Have small data sets or rank-based data. Need a quick and simple calculation without visualization. Thank you for watching. If you found this video helpful, feel free to like, subscribe, and share it with others who might benefit. Thanks again, and we'll see you in the next video.